Hi, this is lesson 1.4, sketching graphs of functions, and basically a review of transformations of functions. Well, there's a few different ways of doing this, graphing functions with using transformations, and we'll take a look at one technique at the beginning here, which is kind of time consuming, but we'll just kind of briefly go over that. So basically, as you look at a function that has been transformed, it's a good idea to identify what the parent function is, and right here you notice that the parent function is y equals x cubed, and we see that there's a negative and then 1/2 multiplied by the x cubed. So what does the negative do to a function? Okay, and then the 1/2. So once you know what those different things do to the parent function, then you can go through and you can actually take some of the points from the parent function and then plot them according to these transformations. So I'll just briefly go through this very quickly, and we see that we've got points here. We've got 1, 1 and 2, 8. Oops, that's not 8. 8's up a little bit higher. And again, -1, -1. And over here is -2, -8 down at the bottom. And of course, right at the vertex is 0, 0. So the negative, that's a reflection in the x-axis. And so then if we were just to do this step by step, we have y equals -x cubed. Then the vertex, nothing happens there. The point at -1, -1 changes to -1, +1. Because we're multiplying all the y values by -1. And then the point here at 1, 1 becomes 1, -1. And then the point at 2, 8 goes to 2, -8. And then the point at -2, -8 goes to -2, +8. Okay, so that's just a reflection in the x-axis. And here's just a quick sketch just to show the what happens with the negative. So all the y values get multiplied by -1. So then the 1/2, that's a vertical compression by 1/2, and so then all we have to do is take all the y values and divide all the y values by 2 to get the final graph. So if we were to now transform that to get the final graph of y equals -1/2 x cubed, then we'll take all these points, 0, 0, -1, 1, -2, 8, 1, -1, and 2, -8, and divide all those y values by 2. That would give the compression, the vertical compression, by 1/2. Okay, so obviously the point 0, 0 stays where it is. The point at -1, 1 becomes -1/2, and the point at -2, 8 becomes -2, 4. Then over on the right side of the vertex, we've got the point at 1, -1 becomes 1, -1/2, and 2, -8 becomes 2, -4. Okay, so then the graph ends up being compressed vertically and a little bit wider. Okay, so it seems a little bit wider. That's not a perfect sketch of the graph, but it does get compressed to 1/2 its vertical distance. Okay, so that's one way of doing it. We could take a look at another one. This is the same kind of idea, but now we notice with this parent function of x cubed, which we have here, that the negative and the third are inside with the x. So if it's inside the function, then that means that it is horizontal. Okay, so negative and then 1/3. So the negative, what does the negative do to a parent function? And then the 1/3 inside with the x, what would that do? Okay, so let's take a look at just step by step here. Negative x all cubed. So in this case, all the x values get multiplied by a negative, -1. So this point at 1, 1 becomes negative 1, 1. The point at 2, 8 becomes negative 2, 8. The point at negative 1 becomes positive 1, -1. And then of course the point at negative 2, -8 goes to 2, -8. And that point is going to be difficult to find here. Okay. So then again, okay, so that's the first part of the transformation where it's reflected in the y-axis. Then for the next part of the transformation, to give the final graph, that 1/3 in with the x, it does not compress the x values by 1/3. It actually multiplies the x values by 1/3 because it's the opposite of what you think, okay, when it's inside with the x values. So we'll take this secondary graph here that we drew, and then what we'll do is, instead of dividing all the x values by 3, we're actually going to multiply all the x values by 3. Okay, so this point at negative 1, 1 becomes negative 3, 1, right there. The point at negative 2, 8 goes to negative 6, 8, which is way out here. The point at 1, -1 becomes 3, -1. And then this point at 2, -8 becomes 6, -8. Something along this line. Okay, so then the graph really gets flat and wide. Okay, so that's basically what the graph's going to look like. Okay, and I'll come back in a couple seconds, or go on to part 2, I guess. Okay, so go on to part 2, and we'll take a look at a different style or a different technique of graphing parent functions under transformations.